Today we are going to start talking about right triangle trigonometry. So first of all, we have to have a right triangle, okay? And these are basically ratios of the sides, okay? So if my T is here, right, that's like my angle here in this particular case, then this is the opposite side of it. It's exactly opposite, right? It's the one that's caught in between the angle that I'm looking at. And then this one is the one that's right next to it. This is the adjacent side. Now, how can I tell the adjacent from the hypotenuse? The hypotenuse is always opposite of the right angle because this is the biggest angle. Because it's 90 degrees, there's only 180 degrees in a triangle, so these both have to be smaller than 90, right? So this is always the biggest one. So this is the hypotenuse over here. Now, something else that we're going to use a lot is the Pythagorean theorem, which basically says that a squared plus b squared equals c squared, where these are the legs of a right triangle, so that would be like the adjacent side squared plus the opposite side squared equals c squared is always the hypotenuse. And this applies only to right triangles, okay? All right, so some of our ratios here, hopefully you've at least heard of these before, but sine of t is the opposite side over the hypotenuse, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, okay? Now those are the three primary ones. Now all the rest of these are all just reciprocals. So I always think of, okay, so tangent and cotangent, these obviously to go together. So the tangent is opposite over adjacent, so cotangent is adjacent over opposite. And, or you can think of it as 1 over tangent, right? There's a S and a C here, and there's an S and a C here. There's always one S and one C in each pairing. So sine and cosecant are reciprocals. So opposite over hypotenuse, hypotenuse over opposite, and secant and cosine are reciprocals. So adjacent over hypotenuse, hypotenuse over adjacent, okay? So let's look at just this triangle here, and we'll just write out all of these. So the sine of t, okay, so first of all, we need to place t. So I'm gonna place, I know that's my right angle, so I'm gonna place t right here. So with t here, this means that 5 is my opposite side, right? So this one opposite is hypotenuse. And if I couldn't tell that, then the biggest number is clearly the hypotenuse because I didn't have to find any. They're all given to me this time. And this is the adjacent side. Okay, so my sine is opposite over hypotenuse, so that is 5 over 13. Cosine of t is adjacent over hypotenuse, so 12 over 13. And tangent of t is opposite over adjacent, so 5 over 12. Okay, now cotangent, I'm just going to write these in, is 12 over 5. It's just the reciprocal. Secant is 13 over 12. I'm writing them with the secant. And cosecant is 13 over 5, right? So it's that simple when we know everything. All right, so let's look at finding all the trig identities. This time I have a side missing. Okay, so according to my theta, what I'm missing here is my opposite side. So this is the adjacent, right? Here's my right angle, so this is the hypotenuse. So how do I find that? Well, we have the Pythagorean theorem at our disposal. So that means the legs, the sum of the squares of the legs, so that would be 3 squared plus, I'll just call this x. X squared equals 5 squared. So this is 9 plus x squared equals 25. So x squared equals 16. I'm subtracting 9 from both sides. X equals, now since we're talking about the length of a triangle in this particular case, we're only going to talk about the positive 4. Normally I would put plus minus here. So this is 4. So now I can figure out everything I want. So the sine of theta is opposite over hypotenuse, so 4 over 5, and while I'm here, I'll just write cosecant theta because that's the reciprocal, is 5/4. Cosine of theta is equal to 3 over 5, the adjacent over the hypotenuse. So that means that secant of theta is the reciprocal, 5/3. Tangent of theta is opposite over adjacent, so 4/3. And that makes cotangent of theta the reciprocal, which is 3/4. Okay, so that time we had to find a side. All right, so there are some special triangles that we're going to look at, and they are, the first one is a 45, 45, 90 triangle. Okay, so that means that these two angles are equal. So this means, so I'm gonna dredge up a little geometry here. What this means for us is that when I have these two matching base angles, that means that this side is congruent to this side, meaning they're the same length, okay? So, since they are the same length, I can think of this, I'm just going to use, for right now, we're just going to use a hypotenuse of 1. Okay, because we're going to eventually put this in a unit circle with a radius of 1. So that's why we keep our hypotenuse 1. So if I know that, then I know that this side and this side, right, they're the same. So I can call them the same variable. So that means these are both my legs, right? So that means x squared plus x squared equals 1 squared. So really I have 2x squared equals 1. And I have x squared equals 1/2 if I divide by 2. All right, so then this means my x equals the square root of 1/2, which I can take the square root of 1, and that's just 1 over the square root of 2. Now 1 over the square root of 2 is perfectly fine, or if you really want to rationalize, this is the way that I learned it, so if I will oftentimes write it like this, just because it's ingrained in my, it's the square root of 2 over 2, because the square root of 2 times the square root of 2 is just plain 2. But this is fine, or this is fine, okay? So that means that this is basically 1 over the square root of 2, and this is also 1 over the square root of 2. So let's look at all of the trig values that go with it. So sine of, I'll say 45 degrees, this is also equal to sine of pi over 4, if I converted it, is equal to, okay, so if my hypotenuse is 1 in this particular case, I just have essentially, well, it doesn't even matter because I'll put my theta right here. But theta would be 1 over the square root of 2, opposite over hypotenuse, which is just 1 over the square root of 2. Or, if you are like me, square root of 2 over 2. Either one is perfectly fine. Cosine of pi over 4, or the cosine of 45 degrees, is also, so if then I have this, that's my adjacent side is also 1 over the square root of 2, and then my hypotenuse is 1, so I just have 1 over the square root of 2 divided by 1, which is just the 1 over the square root of 2, or of course, if you prefer, square root of 2 over 2. Tangent of 45 degrees is equal to also the tangent of pi over 4, and this is 1 over the square root of 2 opposite over 1 over the square root of 2, which happens to be 1. Okay? So then, if I do the reciprocals, my cosecant of, oops, I completely wrote that out of order. Cosecant of, we'll say pi over 4. I'm going to use this one, so when I flip it over, it's just the square root of 2. And let's see, this will also be the secant of pi over 4. If I use this one and flip it over, I just get the square root of 2 because it would be the square root of 2 over 1. If I flip this over and rationalize the denominator, I still get the same thing. And cotangent, the reciprocal of 1, is also 1, so it is still 1. So those are all of my trig identities, sorry about that, for pi over 4 in a 45, 45, 90 triangle. Okay, so one more special triangle. Let me use a different pen because it's a little, the pink I see is a little maybe not quite as visible. So to find a 35 or 30, 60, 90 triangle, what we're going to do first is create an equilateral triangle. Now, what's an equilateral triangle? It is a triangle with all three sides the same. So we're going to call each one of these lengths 1, okay? And that means if these are all the same sides, just like in my my other triangle when I had the 45, 45, that means they'll all have the same angles. So this 360 divided by 3 means that each one of these is 60 degrees. Okay. So now what's special about a 30-60 or a 60-60 triangle is when I drop this perpendicular bisector, it not only bisects this into 2 equal parts, making these a half each, right, because this was 1 total, it also bisects this angle directly in half. So each one of these is 30 degrees. Okay, so I only need one of these because I just need a 30, 60, 90 triangle, but I wanted to show the ratio of the sides here. Okay, so I know that this is my hypotenuse, it's 1. This is right angle because this is a perpendicular bisector when I drop it in here. And I know that this short side here is a half. So now I can find this part over here. So that means I can use my Pythagorean theorem, this squared plus this squared equals 1, right? So that means I have 1/4, because that's a half squared, plus x squared equals 1. I subtract 1/4 from both sides and I get x squared equals 3/4. And then I take the square root of both sides and I get the square root of 3 over the square root of 4, which is 2. Okay? So this over here is the square root of 3 over 2. So let's write out our trig values now. Okay, so we're going to call this first one, we'll go here first. Okay, so this is our 60 degrees. So we're just going to do sine, cosine, and tangent because we can always do the reciprocal every time. So we'll call this sine of 60 degrees, which is also the sine of pi over 3. And that is opposite over hypotenuse. Okay, so that means it is the square root of 3 over 2 divided by 1, so I won't write that. The cosine of pi over 3, right, so then if I wanted cosecant, it would be 2 over root 3. Cosine of pi over 3 is the adjacent, okay, so this half over the hypotenuse, which is 1, so that's just a half. And then tangent of pi over 3 is the opposite over the adjacent. So what I have here is the square root of 3 over 2 divided by a half. And when I simplify this, I end up with the square root of 3 over 2. Actually, it's just plain the square root of 3 over 2, the square root of 3. I'll get there eventually because my halves will cancel because I end up multiplying by the reciprocal, which just ends up being the square root of 3. So the tangent of pi over 3 is square root of 3. Now, you want to remember the sine and cosine. You can build tangent from there in all of these cases. If you can just remember sine and cosine, you can build everything else out of it. All right. So now also this triangle had a 30-degree angle in it. So I'm going to redraw this triangle. Try to make it the same. Okay, so this time we're going to look at this is my angle up here. This is my 30-degree angle. This is still side 1. This is still a half. And this didn't change. This is still 3 square root of 3 over 2. Okay, so my measurements didn't change. It's just that, right, because if this is 30 degrees here, this is 90, that means that this one up here also has to be, this has to be 30 because there's 180 degrees in a triangle. Okay, so if we look at the sine of 30 degrees, which is also the sine of pi over 6, this is opposite. Now here my opposite is down here, right? So that would be a half over the hypotenuse, which is just a half. My cosine of pi over 6, so this time my adjacent side, it's definitely not the hypotenuse, right? So my adjacent side is the square root of 3 over 2, and then I divide that by 1, so it just leaves me with the square root of 3 over 2. And then the tangent of pi over 6 is the opposite, which is a half, over adjacent, which is the square root of 3 over 2. This time, when I invert and multiply, I end up with 1 over the square root of 3, which is perfectly fine. Perfectly fine. If you really wanted to rationalize it, it would end up being 3, actually the square root of 3 over 3. But 1 over the square root of 3 is perfectly fine. I do not require that you rationalize. All right, so those are my special triangles, and we will practice some more trigonometry soon.